given that sine of theta is equal to 2/3 and cosine of theta is less than 0, determine the exact values of sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So for these, we're going to be using our double angle identities. Sine of 2 theta is equal to 2 sine of theta cosine of theta. Now we know sine of theta is 2/3, but cosine of theta we don't know. All we know is that it's negative. So we're going to have to find cosine of theta. What we're going to do here is just draw a little picture of what we know about our angle. First of all, sine of our angle is a positive 2/3, so we know that if we draw our angle in standard position, it's going to be up here in the first two quadrants. But we also know that the cosine of the angle is negative, so that only happens in the second and third quadrants. So we know that our angle is going to have to be drawn here in the second quadrant. And so we're going to go and just draw an angle. And sine, we know, is opposite over hypotenuse, or we could think of it as simply the y-coordinate on the unit circle. I'm going to think of it as opposite over hypotenuse. So here's my opposite, 2, hypotenuse of 3, and then I get this side right here using the Pythagorean Theorem. Now the Pythagorean Theorem, if I call that a, says that a squared plus 2 squared is equal to 3 squared. So I get a squared equals 9 minus 4, which is 5. So a is the square root of 5. Now this is where it's important to know that because I've drawn this here in the second quadrant, this a actually has to be a negative number. So this is going to be the negative square root of 5. Okay, so now I just go here and I fill it in. I say, well, sine is 2/3, of course, and cosine is adjacent over hypotenuse. So that's going to be a negative root 5 over 3. And then we can simplify a little bit. This is 2 times 2 is 4, so I get negative 4 root 5 over 3 times 3, which is 9. Now for cosine of 2 theta, there are actually 3 different identities for this one. I'm actually going to use the one that uses the sine, which is 1 minus 2 sine squared of theta, because I already had the sine here. So then I just plug in what I had. 2 times sine of theta is 2/3, so this is 2/3 squared. And then I simplify. This is 1 minus 2 times 4/9. That's 1 minus 8/9, which is, of course, 1/9. Okay, and then we need tangent of 2 theta. Tangent of 2 theta. Our formula is 2 tangent of theta over 1 minus tangent squared of theta. And then we already have our triangle here, so we can just plug in what we know. Tangent is opposite over adjacent. That's 2 over negative root 5. And then over, I've got 1 minus, and then that's 2 over negative root 5 squared. And then we can simplify a bit here. So I've got here, this is a negative 4 over root 5, okay, over 1 minus, this 2 squared is 4, negative root 5 squared is just 5. So I've got negative 4 over root 5 over, this is 1/5. Okay, now I can, I'm dividing by fraction, I can flip and multiply negative 4 over root 5 times 5 over 1, which is negative 20 over root. We can rationalize the denominator if you'd like, multiply by root 5 over root 5. And that gives us negative 20 root 5 all over 5. And then finally, 20 over 5 reduces down to 4. So we finally end up with negative 4 square root of 5.